And I would like to discuss with you quantum humanism, which is a strategy to overcome the problem of the tension between humanism on one hand and quantum mechanics on the other hand. As you all well know, probably the first who actually acknowledged that there was a tension between quantum mechanics and Humeanism was the father of Humean supervenience, David Lewis, and he pointed to non-locality as expressed by the Bell's inequality as really the core of the threat against Humeanism, his view. So what's the problem when on one hand we have the Humeans who claim that the mosaic, which is our fundamental ontology, is really local, which means that actually the complete physical state of the world supervenes on the intrinsic physical space of point-like objects or space-time points, and that even all other facts, even nomological facts, can actually supervene on this physical state. And of course, by supervenience, I mean that if A supervenes on B, any change in A must correspond to a change in B. And then on the other hand, we have quantum mechanics. We have entangled states like the following: entangled wave functions, even maximally entangled states like the singlet state and the triplet states, where they clearly tells us that, for instance, if we want to measure the spin of two electrons along the z directions, and then we know that actually the spin of A electron, for instance, is up, then we are also sure that the spin of the B electron will be down and vice versa. And so, well, Bell's theorem really tells us that this non-local feature is real in quantum mechanics. But then what can we do? Well, as a Humeans, we can actually say, well, look at this entanglement state, so this entangled wave function can actually supervene on the intrinsic states of electrons or not. Well, the problem of this tension between humanism and quantum entanglement is exactly that the answer is no, because even if we try to specify the intrinsic states of the electrons, so then we would use mixed or impure states, and then we would come up with the mosaic, which is actually the same for both the triplet state and the singlet state. And this would contravene, would violate the relation of supervenience, because we would have two different entangled states, the triplet and the singlet states, kind of supervening the same mosaic, which is something that is not possible within superhumanism. So this is the problem, right? So we know from quantum mechanics that non-locality cannot, so we know from Humeanism that non-locality cannot be fundamental, but we also know that if we try to say that non-locality supervenes on the mosaic, actually we would violate the definition itself of supervenience. And so the problem is, okay, Humeanism cannot accommodate entanglement states, entangled wave functions. So one of the most popular solutions to avoid this problem was really to regard the entangled wave functions as belonging to more the nomological part of the theory rather than some ontological features of the theory that should supervene on the mosaic. So the thought was, well, look, the wave function, the entangled wave function, is part of the laws, and laws of nature, of course, supervene on the on the mosaic from the beginning of when it was born, the mosaic, until the end. And this kind of solution was developed by several philosophers who are here also now. So Callender, Vogel and Perry, Miller, Asphalt, Chen, and other people. In this talk, I really would like to focus on the quantum humanism view, which is really part of this strategy of putting the wave function in a nomological part of the theory. And the reason why I got fascinated by his account is that I think it's particularly rich. He uses many different metaphysical conceptual tools, ranging from the best system account, functionalism, identity reductionism, primitive ontology. And it seems to me that there is so much work to do here. First of all, because it's interesting to see how all these conceptual tools place together, and also to check whether they can actually form a coherent view. And it's exactly in this regard, in coherence, that I have some perplexities. So I want to present any knockdown arguments against quantum humanism, but more some challenges, because I would like that these challenges can render quantum Humeanism more robust. So the plan for today is, well, I've already told you what the problem between quantum mechanics and quantum Humeanism is, and Humean supervenience is. I will now tell you what Esfel's solution is, called quantum Humeanism, and then some challenges which I think might be some threat against his account, and then my proposal, which is to frame Esfel's view within the so-called Humean fictionalism. Okay, so what is quantum Humeanism? Well, so first of all, we have to say that Michael Esfeld really adopts a kind of Canberra, tries to implement a kind of Canberra plan. So he has a very minimal ontology. So he endorses the primitive ontology approach, according to which our fundamental ontology, and it's composed by particles in their spatial temporal relations, so particle trajectories. And this, of course, is dictated by some armchair metaphysics view that we need to have the most minimalistic ontology, but also from some kind of empiricist view, according to which we actually only see and measure particle positions. At least this is what he endorses. So what about the wave function? What about the quantum wave function? It's not in the primitive ontology. So what can we do? Well, since according to the primitive ontology, we should commit to the existence of only the primitive ontology, then the wave function should not be regarded as really existent. So how can we account for the wave function? Well, as for the view is that actually the wave function is a dynamical parameter which appears in the dynamical structure of the theory. And since Michael Esfeld also endorses the best system account of lawhood, then we can say that the wave function is a dynamical parameter which appears in the best system of lawhood for quantum mechanics. So now the question is, but what's the relation between the wave function and the primitive ontology? So here I collected some quotes from Michael Esfeld, where he actually tries to explain what's the relation between the wave function and the primitive ontology. So he says the wave function can therefore be taken to be located in the motion of matter, as defined by the change the distance relations among the particles. So here we say, okay, the wave function is located in the primitive ontology because it's defined by the change of the primitive ontology, so by the trajectories of the primitive ontology. And then he also further explains what he means by location. So he understands location by a relation of identity. So he says everything else which is not the primitive ontology is located in the set of the primitive ontology in being identical with something in the set, okay? So in his view, supervenience is just a way to establish identity and ontological reduction. Another very important point is that this kind of supervenience relations really obtains between the wave function and the whole motion of trajectories from time zero until the very end of our space-time, okay? And this is why even the initial values of the wave function, or the initial wave function of our system, actually depends on the future motions of the particle trajectories. So in order to specify even the initial values of the wave function, we have to wait until the end of our universe, because otherwise there will be some kind of underdetermination. Then he also understands this location and identity relation as meaning that actually all the propositions that describe the primitive ontology actually entail all the true propositions about the world, so even including propositions about the wave function. And lastly, he introduced functionalism to understand the wave function. So he says, look, the wave function is introduced through a functional definition that describes its causal or functional role for the behavior of the entities in the primitive ontology. So the wave function has some kind of functional or causal role in order to accounting for the behavior of the entities in the primitive ontology. And so the function of the wave function, the benchmark for the wave function is also that enables the formulation of laws to simplify the representation of the change. So here I see two different ingredients. On one hand, the wave function is introduced through this causal or functional role to account for the behavior of the entities. On the other hand, it's it has an additional role, which is that enables the formulations of laws that are simple. And so we don't really need to list all the changes of trajectories in the primitive ontology. We just need to write things down in terms of the wave function. So here I extract three different theses about the wave function, which Michael Esfeld endorses. The first is that the wave function is an homological parameter that makes the laws of nature simple. The second is that the wave function is located in terms of like identity in the particle trajectories via its functional role. And third is that the initial conditions of the wave function depend on the future trajectories of the particles. So here I have some perplexities because it's harder for me to actually put everything together. So when I ask the question, what is the wave function within quantum Humeanism as well as quantum humanism, then I try to think of the best system account of which is normally the most popular way to account for laws within Humeanism. And Michael Esfeld endorses the best system account. And according to best system account, as we said before in our previous talk, then normally, originally, the predicates that we should use in our laws of nature should be natural predicates that refer to natural properties. But of course, this can't be right for quantum humanism, because within quantum humanism, the only natural predicates are particle positions. So then the second options would be like to go as Vogel and Perry did in their paper and we discussed just now. And so to think, okay, the wave function maybe comes as and interpreted in the laws like chance or the wave function in Vogel and Perry account. So this might be an option. But then, I mean, this insistence on functionalism, identity, and location is actually some reason for me also to opt for another option, which is that actually wave function is a kind of like interpreted predicate, but it's not fundamental. It can be interpreted in terms of the primitive ontology. It has some correspondence with some properties of the primitive ontology. And so we would have non-fundamental but interpreted predicates in the laws of nature. So I will exclude one and then we'll investigate 2 and 3, and I will start with the 3. So according to 3, the wave function actually should be and can be paraphrased in terms of particle trajectory. So the wave function refers to some types of particle trajectories. We can think that the wave function maybe it's an abbreviation or maybe a higher level property of some kind of particle trajectories. But in any case, what's important is that there is a clear correspondence between the wave function and the particle trajectories. So this insistence on the wave function is really and in linking this with actually the functionalist, a kind of functionalist account, it really reminds me of how Lewis and Jackson treat pain. And actually, Michael Esfeld really refers a lot to these two philosophers. But then, so in order to understand how functionalism and identity work in their scenario, it's quite plain because and quite clear because they said, well, look, Pain can be identified with the C fiber firing because the causal functional nexus that defines the pain is the same causal functional nexus that then defines the C fiber firing. So we can say that that pain and C fiber firing are identical. So in this case, functionalism, location, and identity can work well. But then here I have some question. I mean, what is exactly this functional causal nexus that defines the wave function and at the same time the kind of trajectories to which the wave function refers to? I mean, the wave function is introduced, as we said before, using Michael Esmond's word to account for, to explain the motion of trajectories and to make laws of nature simple. But it doesn't seem to me that kinds of trajectories are introduced in the laws to serve these two functions, right? Also, the problem is also about simplicity. If we think, as we did before, that actually the wave function can be paraphrased, can be rewritten in terms of more fundamental kinds, and so in terms of natural kinds, natural properties, and so particle positions, then, I mean, in order to judge whether the laws of nature are simple or not, we would have to rewrite actually the laws of nature in terms of natural predicates, and then to see, to check which actually is whether the laws are simple or not. But of course, this is not the case, because once we rewrite things in terms of particle trajectories, then we have something very long. And this is exactly the function of the wave function, which is to make things simpler in a kind of tricky way. So then the third perplexity that I have is, if we have this kind of correspondence between the wave function and some kinds of particle trajectories, why do we have to wait until the end of our time to know what the initial conditions of the wave function are? I mean, why we have this underdetermination until the end? We just know that the initial wave function should correspond to the initial particle positions of our system. Okay, so let's go to the second option and think, okay, let's do like Bogle and Parry did for the wave function. Probably Michael is interpreting that also in the same way. The wave function comes uninterpreted in the laws of nature, okay? And then it makes the laws of nature simple, okay? But then, so in this framework, what does it mean to say that there is a wave function? Oh, well, it just means that there is a candidate system which turns out to be the best. And actually, in this system, the wave function appears. So I find some challenges for Michael also if he thinks that the wave function comes uninterpreted in the laws of nature, because then it doesn't make sense. All his talks about functionalism and causal functional role. I mean, how can an uninterpreted term provide a causal or functional explanation for the motion of the particle? Also, we can't really talk about identity here. We can't say that the wave function is located or it's identical to the particle trajectories. Also, I find it a bit bizarre that we can say that the truth about the primitive ontology can entail truth about the wave function. Also, in Michael's view, since he not only regards the wave function as this dynamical parameter, but also energy and the Hamiltonian and other things appearing in the quantum laws as uninterpreted term, then we would have a bunch of laws all with uninterpreted terms, and this I find particularly bizarre. So let's sum up and see things from a more general point of view. Here we have evaluated two different options. The first was actually to reject the face value interpretation of the wave function, and so sentences of the function, because we know that actually when we talk about the wave function, we know about some kinds of particle trajectories, okay? So we can still think that these sentences about the wave function are true, right? Because we know that actually we mean particle trajectories. But then I found lots of challenges about this, okay? The paraphrasing wave function is challenged. It doesn't really make sense to define the wave function and identify it with particle trajectories by appealing to a causal nexus or functional nexus. So we found it a bit unfeasible. The second option that I was looking at was say, well, we reject the face value interpretation of the wave function and sentences on the wave function because actually the wave function comes as uninterpreted, and so it doesn't have a semantic value attached per se. Of course, we can recover some kind of meaning because we have some bridging kind of propositions that bridge propositions about the primitive ontology and proposition about the wave function, but in any case, the wave function comes uninterpreted. But then we found that there was a very bizarre to accommodate talks about functionalism and identity within this scenario, so we ruled out as non-feasible. So there is another alternative. Well, my third option would be to interpret quantum Humeanism as a sort of thesis like the following. Well, we accept the face value semantic of the wave function. When we say wave function, we just mean what mathematicians and physicists say. Wave function, it's a complex valued field in high configuration space, or it's a vector in Hilbert space, whatever. But then we reject the truth of the sentences expressed in the wave function. And here I want to say this a little bit more precisely. What I mean here is that the sentences about the wave function should not be interpreted as strictly speaking expressing the truth outside the dynamical structure. And what I mean here, well, my suggestion here is to go for a fictionalist approach to the quantum state. So we know that fictionalism has a very honorable tradition as being applied to ethics, religious matters, so on and so forth. And primarily it targets the ontology. So we pretend that God exists, but actually we know secretly that it doesn't. We pretend the moral values exist, but actually we know that strictly speaking, they don't exist. We pretend the mathematical entities exist, and we write down quantum mechanics with mathematical entities, but actually we know that they don't exist. And in this tradition, there is a particular kind that might be appealing, but that I'm not going to adopt in this talk, but just want to flag this. Well, we have nominalism in philosophy of mathematics, which takes mathematical entities to be fictional. And in this regard, Eddie Chen has actually worked out an intrinsic theory for quantum mechanics, according to which we can actually reduce the quantum wave function to actually relations in regions of space-time, as Arthur Field did for other theories. So I do not go into this direction, however, because within Eddie's chain view, actually, the primitive ontology is a kind of like surplus. Once you actually reduce the quantum state to relations on regions in space-time, then after that you can choose the ontology you want. But Michael Asfeld, in his view, keeps saying that the wave function has some kind of relation to the particles, so to the primitive ontology. So this is fixed. So my proposal is actually to go for Humean fictionalism as developed by Varzi in 2013, and see really can be a good option to understand quantum Humeanism. So what is a Humean fictionalism? Okay, so let's think about Hume. Okay, according to Hume, causation was just a concept that was not corresponding to the feature of reality. Why? Well, he had a very empiricist kind of approach and was like, well, look, I just observe succession, contiguity. I don't observe causality. The same kind of spirit, I find it in Asfeld's writing. I mean, the wave function is not a natural feature of reality. We don't see wave function. We only observe particle position, according to him. So he also has this kind of empiricist approach. What else to say about the Humean fictionalism? Well, according to Humean fictionalism, we can literally interpret our laws of nature and the entities that the laws of nature postulate. But then secretly, we know that they are fictionalist structures using fictional entities, okay? So And you know, these fictional entities have the very same kind of properties that normal entities have. So they can be more or less simple, they can be more or less fundamental, etc. But we just don't have to believe in their actual existence. So what about the wave function? We can say, well, the wave function is a part of a fictional structure which does not reflect the structure of reality, but rather helps us make sense of reality by structuring the scattered multitude of our empirical data. So Humean fictionalist is also a great view because actually it's not fundamentally ontological. So the fiction concerns the nomological, the dynamical structure. So it's compatible with metaphysical realism, okay? Humean fictionalists just say, look, we should not confuse the structure the reality has with the structure that we use to make sense of reality. And this is exactly what happens in Aspel's view. He's a fictionalist about the structure of the laws, because he said, well, our structure of our laws is ontologically insignificant. But then actually he's a very strong metaphysical realist. And also because of his fictionalism, he endorses a very parsimonious view about the primitive ontology, because he doesn't have to believe to the entities that, you know, the structure of the laws imply or entail. So now I just want to finish in this 2 minutes I have and to say, well, look, the question that I would like to ask is not really whether Aspel would be happy with this Humean fictionalist stance that I'm proposing. The question that I find it intriguing is whether there is room for such a stance within Aspel quantum humanism, and whether it makes actually his view stronger and more robust. And here I have to say something. So first of all, I think it's good because it preserves a local ontology, which is what Humeans want. It avoids the many important problems that we saw before, like the challenge of paraphrasing the wave function, the challenging of having uninterpreted language in the laws. It actually even explains why we have to wait until the end to have very precise, to know what the initial conditions of the wave function are, because of course we want to have the best fictional characterization of our scenario. And of course, in order to know whether it's the best, we have to wait until the end to see whether things work fine. Also, we can still accommodate Aspel's use of functionalism in the sense that actually these fictional entities are indeed introduced to explain particle motions and actually to make the structure by which we make sense of reality the best structure possible we could have. But of course, there are problems. First of all, there is no identity, but I don't know, because I thought that within quantum humanism, identity was kind of tricky. So I'm not sure whether considering it cons or pro. But then, yeah, there are other problems, which is exactly this, that we don't have anymore the so-called standard best system accounts. Why? Well, because we don't have any more nature properties in the law of nature. We don't have actually laws that cover nature at its joints. This is a problem. But come on, I mean, this was not even really what Aspel was doing. I mean, Aspel's scenario was not endorsing a proper best system account. And also, there are many Humeans who do not believe in the BSA account. I'm actually also sympathetic with Hicks and Schaffer's view that laws of nature do not endorse, do not use natural predicates. And also, we will not even have, with this fictionalist Humean approach, one of the most challenging problems that we have by discarding the best system account, which is normally we say, well, we need the best system account, otherwise every irregularity would come up as low. But no, we don't have this problem. And this is why we still have a kind of a system, because we can still say that this is our best fictional structure that we could have. So we can say that the laws are the simplest and the strongest, and that laws that give us the most convincing and best structure we could have or have. And this is why we should believe in it. We would be so silly not to believe in the laws of nature, okay? And also, our new best system account will still allow for a literal translation of the predicates in our laws. So that is so cool. Okay, so I still have work to do. I'm sure about that because I didn't tell anything about how these fictional entities are connected with our primitive ontology. And so I'm halfway done. But in any case, I don't think that this might make my view less strong than Essel's view, because Essel's view also does not really specify what the connection is, and introducing entailment and functionalism and identity was, I think, a bit challenging. My working hypothesis is just that, look, the connection between these fictional entities like we function and the primitive ontology is just, well, look and read all Schrödinger and de Broglie correspondence at those time. I mean, it's clear why some mathematicians and physicists working on quantum mechanics were introducing the quantum wave function, okay? And so we don't really have to establish a sort of kind of ontological connections between the two. So my conclusion is, I don't know, I found some challenges for and perplexities by reading Essel's Quantum Humanism. I don't know if you find my perplexities convincing. I propose the Humean fictionalist, according to which wave function is a fictional entity, part of a fictional structure. Of course, I still have my homework to do, but I don't know, maybe Humean fictionalism can be a promising proposal for any Humean approaches to the quantum state. And so here I have some references, but I would like to thank Michael Esfeld and the Lausanne group for hosting me for last semester, Christian Lopez, who was in Lausanne as well, and you all for inviting me and for listening to me. Thank you so much.